Hi Danny, welcome to today's lesson. We are going to go over lesson number 21, which goes over prime and composite numbers and then prime factorization. This is how we learn how to factor, how to find those prime numbers within a composite number. So here we go. And I'm really sorry about today's lesson because for some reason the GIF thing is not working, so I can't pull in like funny little videos, and I'm so sad about that. So it's not going to be as entertaining as usual, but hopefully we'll still get through it. I don't know. What do you think of this sign? Would you buy fasteners from this aisle? Pretty ironic, that sign, huh? All right, let's go into counting numbers and natural numbers. This is just a reminder that when we start talking about counting numbers and natural numbers, you're going to have to remember what those are. And basically what it is the numbers when you start counting something. 1, 2, 3, 4, 5. Like if you see a bunch of things and you start counting them, it's those numbers. So it's a whole number, and you start with the number 1. Okay, makes sense. Now let's look at factors. Basically, what this means is that every one of those counting numbers, 1 through 10 and on to infinity, they're going to be one of two types of numbers. It's going to be either a prime number, which you know what that means. It's divisible only by 1 and itself, or it's going to be a composite number. Composite means that the number is composed of composed of three or more factors, because if it's just 2 factors, then it's a prime number. So here's some of the factors of the first 10 counting numbers. So look at 1 through 10 right here. The number 1, the only factor is 1. You can only divide it by 1. Number 2, you can divide it by the number 1 and the number 2. 3 is also a prime number because it's divisible only by 1 and itself. But once you get to 4, you're going to start seeing some composite numbers. So 4 is a composite number because you can divide it by 1, you can divide it by 4, but you can also divide it by 2. So that makes it not a prime number, it's a composite number. 5, we're back to prime, only 1 and 5. 6 can be divided by 1, 2, 3, or 6, and you'll get a whole number, not a fraction, right? 7 is a prime number. It can be divided only by 1 and itself. 8 is another composite number. 1, 2, 4, 8 are the factors. 9, the factors are 1, 3, and 9. And 10 has the most factors out of this list. Actually, no, it ties with 6, doesn't it? But the factors for 10 are number 1, 2, 5, and 10. It can be divided by all of those. Okay. So these are the numbers 1 through 10. These are its factors. Okay, so if we were to define a prime number, it would be this. It's a counting number greater than 1, whose only factors are the number 1 and then the number itself. So if you look back at that table, you can see that the numbers that are prime numbers are going to be 2. It can't be 1 because it said greater than 1, right? So it has to be 2, 3, 5 is a prime number, 7 is a prime number, and that's it, right? Those are the primes as far as 1 through 10. All right, let's jump into example 1. We're going to make a list of the prime numbers that are less than 16. So I wrote down all the numbers. I did not include the number 16 because it says less than, but not less than or equal to. So these are the counting numbers from 1 to 15. A prime number has to be greater than 1. So I'm going to cross out the number 1 right away. So I know it can't be that. The next number, let's look at the next number, number 2. That has only 2 divisors, 2 factors, 2 things that you can multiply to get the number 2 is the number 1 and itself. So 2 is a prime number. Let's circle that. Sweet. 3 is also a prime number. You can divide it by 1 and itself. What about the number 4? Let's do that one next. You can divide it by 1 and 4, but you can also divide it by the number 2. So when we look at this 2, we see that this can be divided only by 1 and itself, but any even number that is past that can also be divided by 2. So that means these are not going to be prime numbers. Those are all composite numbers. So we can just automatically cross out any number that is even. Oops. Let's do that again. Any number that's even and greater than 2. I know those are not going to be prime numbers. Right? Okay, so let's look at the numbers that we have left. We have the number 5. That can be divided only by 1 and itself, so that's another prime number. 7 we said was prime. How about 9? 9, the factors are 1 and 9, but what else? If you remember your multiplication facts, 3 times 3 makes 9. So that is a composite number, and we can cross that out. What about 11? 11 is a prime number. You can't divide it by anything and get an even number other than 1 in itself, right? 13, same thing there. That's another prime. And then 15, if you remember your math facts, you could do 3 times 5 is 15. So that is not a prime number. I'm going to cross that out. So the list is 2, 3, 5, 7, 11, and 13. All right, let's jump into example 2. Now they want us to list the composite numbers between 40 and 50. So I'm just going to list those out. I started with 41. I ended at 49. Now, so any number that is divisible by a number that is besides 1 or itself has to be a composite number. So that means all the even numbers on this list are composite because they're divisible by 2. So let's go ahead and circle all the even numbers. Those are all composite numbers because you can divide them by 2. Now that leaves the odd numbers to look at. What about 45? Let's start there. If you remember your math facts, you can, well, basically it ends in 5. So that means it's divisible by 5. Anything like 40, 45, 50, 55. All of those numbers are going to be divisible by 5. So that makes that one a composite number too. A composite number as well. So let's go ahead and circle that. What about the number 49? You remember that math fact, right? 7 times 7. So that's going to be a composite number. Let's circle that. The remaining numbers, 41, 43, 47, those are prime. So you're not going to be able to think of any math facts that end with those numbers. So we'll just call those numbers prime. The ones that are circled are composite. Cool. Let's look at prime factorization. I don't know why I say it that way. Anyway, let's look at all of these composite numbers. When you look at this chart, like 4 is a composite number. It can be composed by multiplying 2 or more prime numbers. These factors are things that you can multiply to get this composite number, and these are, turned out, these are going to be prime. So it's like breaking this number down into its prime numbers. Same thing with 9. We break this down into its prime numbers. Okay, so let's look at this list and make sure that all of these make sense. 14 is 2 times 7. Those are both prime numbers. 6 is 2 times 3. Those are both prime numbers. Let's get to some of these hard ones. What about 8? 8 could be thought of as 4 times 2, right? But 4 is not a prime number. So if you break down 4 even further, it would be 2 times 2 times 2. And that's how you get all of these prime numbers that multiply together to get 8. Here's 12. 12 can be thought of as 6 times 2, right? But 6 is not a prime number, 2 is. So if we break down that 6 a little further, it would be 2 times 3 times 2, which is the same as this. It doesn't matter which order you put it in. Those are the numbers. 16, I think of that as like 4 times 4, but those are composite numbers, so we break those down. It would be 2 times 2 times 2 times 2. So that's prime factorization of the number 16. So when you write a composite number as a product of prime numbers, so if all these are prime numbers and you multiply to get them together to get a composite number, you just factored it. You just did prime factorization of that number. Let's do example 3 and then you'll get it. Write the prime factorization of each number. Now there's 2 ways to do this, and the way that I like to do it is this. You take the number, they want us to factor this. I'm going to get rid of that 81 right there to make it easy. And there's 2 methods. I like the factor tree. Factor tree means that you break this down into a multiplication problem that you know. So 30 is going to be 3 times 10. Okay? Once you get to a prime number, you can stop on that branch. So I don't have to do that branch anymore. But 10 is not a prime number, so I have to break that one down further. So let's break that down into a multiplication problem that I know. It's 2 times 5, right? And then it turns out that 2 is a prime number and 5 is a prime number, so I'm done. I just broke down 30 into its prime factors, 3, 2, and 5. And it turns out that 30 is equal to 3, whoops, I didn't write that very well, but let's try that again. Okay, 3 times 2 times 5. Everything that I sort of ended with at the end of the tree, that's the prime factorization. Let's do it again for the other number, the one that I erased. They wanted us to do it for 81. Okay, 81. I remember my math facts, right? 81 is 9 times 9. But 9 is not a prime number. You can break that down further. So this one breaks down as 3 times 3, and this one breaks down as 3 times 3. So and now all those 3's, those are prime numbers. So now I did prime factorization. 81 is 3 times 3 times 3 times 3, and I just factored it. Okay, sweet. Let's do a really hard one. The other one that they wanted us to do, the other number, is a big number. So let's do it and make sure that we can do this with a big number. It's just as easy, don't worry. 420. Now, I don't automatically know a math fact in my head that goes with 420, but I know that can be divided by 2, and it would be 2 times 210, right? You can just do that in my head. And then 2 is a prime number, so on that branch I can stop. But 210 is not a prime number, so I can divide that by, well, if I just look at it, it can be 21 times 10, right? These numbers are also not prime, right? So 21 can break down into 3 times 7. 10 can break down into 5 times 2. Now, those are all, what I'm left with here, those are all prime numbers. So now I have to circle all the prime numbers. Don't forget that 2 way up there, and then you've got 3, 7, 5, 2. And then I'm going to list them all, and I'm just going to do it in order from smallest to largest. So it's going to be 2 times 2 times 3 times 5 times 7. Make sure you get them all. So there were 2 2s. You have to list them both. If you do that multiplication, you should get 420 as your answer. Okay. Example 4 says write the prime factorization of 100 and then square root of 100. All right, let's start with the 100. 100, what could be a multiplication fact that gets you there? What about 10 times 10? Okay, great. This is going to be 2 times 5. This is going to be 2 times 5. Okay, so that's it. 2 times 2 times 5 times 5 is 100. Easy, that was so easy, right? What about square root of 100? That seems a little more tricky. Okay, so what are 2 numbers that you can multiply together to get square root of 100? First, let's solve. What is square root of 100? Square root of 100 is equal to 10, because 10 times 10 is 100, right? So let's just do prime factorization for the number 10. And that would be it. So that's actually way easier than it seems. So it's just 2 times 5. Okay? All right. So, and that makes sense. The reason they had you do both of those is because square root 10 or square root of 100 and 100 basically have the same factors, but this one is just half as much. Okay. The other way to do prime factorization, which I don't really love this way, I think it's like a little bit more complicated, but you can choose which way you like, is to do a division problem. So if you start with 420, what you're going to do is you're going to find the lowest prime number that you can divide into that, so that will be a divisor. So since this is an even number, I know you can divide it by 2. And when I do that math problem, I get 210 for my answer. Then I just leave that there and I do that again. Divide it by another number, the lowest number that you can think of that's prime. Okay, but it has to be prime that you divide it by. So 2 again, and you'll get 105 for your answer. Now let's divide that. 105 can be divided by 5 or it can be divided by 3. Let's divide it by 3. And if we do that, we'll get 35 for an answer. Just keep going. 35 can be divided by 5. You get 7 for an answer. And then 7, if you divide that by 7, you get 1. So that means 7 is a prime number. So all of these are your prime factorization right there. So that's just the other way to do it. You can choose which way is easier. I personally like the tree. All right, that's it. That's the whole lesson. Love you, Danny. Bye.